Hey guys, Braxis here, and we're playing some Space Engine. So, as always, it's been a little bit since I've done this. Where am I? Oh, that's a pretty view. Where is this? This must be where I left off. Oh, look at that hurricane there. Oh, look at that. It's like a cone. Oh, that's cool. Okay, I think I'm on... Oh yeah, I'm probably on a... No. Oh, okay, now I remember. I'm in a valley. Okay, yeah, I remember this crater. Yeah, I remember this at the end of the last video. Was this a screenshot? No, it wasn't. Oh, that's a pretty cool view. I like that. Anyways, yeah, I'm going to be checking out some suggestions, as always. And, it's kind of cool watching this in real time. Just watch it very, very slowly move across the landscape. I can kind of see it. I don't know if that's showing up much in the video. Okay, but, yeah, I got some suggestions, which to keep in mind, I only do suggestions on the latest Space Engine video now, and up to 2 suggestions per person. I figured I would just mention this because some people did make some suggestions on other videos, and I am actually going to skip over those, because I'm currently just looking at the comments on my latest Space Engine video. So I figured I would mention that, and that's how it's going to be for, like, the last video and on. So I just figured I'd mention that. The first one I see here is from Heavy Weapons Guy, and it was 11 hours ago. He says, a dead gas giant. So let's go ahead and check that out. Let's go ahead and copy the ID here. Okay, let's just paste this in, remove that question mark. And here we go. Oh, this is in the Carina Nebula. So this is a dead gas giant. Why is this dead? Why would this be dead? Moons orbiting around it? Is this a gas giant? Okay, yeah, I think it is. No, there's actually no moons orbiting around it. Oh, wait, yeah, there is. But they're all asteroid moons, I think. Yeah, they're all just hot asteroids. That looks kind of like a planet over there. No, it's not. It's just be a large asteroid. What's the diameter of that? 361 kilometers. So that's almost a dwarf planet. Pretty cool. That's a nice big round asteroid. Probably even might have a molten core in there. Who knows? But pretty cool. You can see all these bright objects around this gas giant. In fact, that has a lot of them. Does it mention the number of moons? 46. So a lot of asteroids. And like I said, this is next to the Carina Nebula, which is a supernova, I do believe. Let's see if I can back out and get this selected. There we go. Yeah, it says diffuse, but I do believe this is actually a supernova, and there is our Wolf Riot star, as you can see, with that kind of outer shell just being ejected out in kind of a violent fashion. You can see that there's actually a smaller cloud in the Carina Nebula. Can I select that? Ah, yeah, the Keyhole Nebula. Keyhole Nebula. I can't really see how that's a keyhole, but I'm sure from the angle of Earth, and in a much higher resolution picture, it probably looks like that. So let's go back to this gas giant, which is right here. So this is apparently a dead gas giant. I wonder why he mentions that. Not sure. Let's press... Well, that's a white main sequence star. Is this thing... It's 148 degrees. It's not too hot, actually. Nothing compared to this Scorched desert over here, which is tidally locked, I do believe. You can barely see it. I think I have the real planet brightness on, so let's just turn that off. So we can actually see, like, the detail of these lovely planets. And it has a thick atmosphere. We've been to quite a few of these. I'm liking this gas giant over here. I actually like the rings on it. Right there. Nice separated rings, a couple smaller bands in this inner one here. And you can see some kind of dull, but there are some more bands there. Very nice. Let's set F2 again, and let's check out this Frozen Titan and turn on the real planet brightness. So here we go. Is there a hotkey for turning on the real planet brightness? If so, do let me know. That'd be actually kind of good to know. That way I could just cycle through that very quickly. These are always beautiful when you land on them. Nice dim kind of atmosphere. There's the bright star up there in the sky. And I'm wondering, should I change my diffraction spike effect? I've been using this one for many episodes. Wonder if there's one I should use. Not a big fan of that one. Mainly because it's colored. That is a white star, and the fact that that's yellow just kind of bothers me. I think that is, Kepler? That might be Kepler telescope. Kepler. Is it Kepler? I think that might be Kepler. And the little cross effect, that's like the shape of its aperture. I think so. Let me look up some Kepler photos real quick. Yeah, I'm pretty sure that's Kepler. It would be at like a kind of 45-degree angle, but it doesn't let me actually do that. Actually, that's like a hexagon aperture. That's another hexagon one. That one's actually kind of nice. Duality. That one kind of shows it. I just don't know if that would change color with the star. Astroniki? I think that's the default one, actually. I use the anamorphic one. The lens flare, well. That actually looks kind of cool. I kind of like that. Duality actually looks pretty nice when you do that. Whoa, that is crazy. That's too much lens flare for me, personally. Eden, that's like the standard. This looks like the stock lens flare that's on like Photoshop right here. That'd be like every layer of the lens just kind of getting like a small reflection on it, and that's what that would look like. No, I still think I prefer the anamorphic one. With, if I was going to choose a lens flare, it'd probably have to be this one. Just because it's not really too intrusive. I could use the anamorphic lens flare, but I think that is crazy. Be dubstep montage, so I just keep lens flare off personally. But, yeah. Very cool. This is a frozen world, so I don't imagine there's going to be polar caps. Oh, and it actually has a nice big moon next to it. I'm actually uploading my latest SpaceEngine video, which is kind of the evolution of the sun. I'm actually uploading that without like any refresher or anything on it. I'm just kind of uploading to like my current knowledge. It's been a while since I've been in like grade school, so I have not actually refreshed myself too much on it. I did read an article after I recorded the video though, and I made some small corrections in post. Basically, I left out the planetary nebula and all that kind of stuff, and yeah. But that's like the shortest phase of the star. In fact, most of the nebulas you see around the Milky Way in this game are actually planetary nebulas. You don't actually find supernovas very commonly. A pretty uncommon event because the majority of stars are actually sun-like stars. They're rather small. So you see things like planetary nebulas quite frequently. Like if I turn up the galaxy magnitude here, you'll start to see that there's all these lovely colorful objects, all these reds and blues and even like purples and greens and stuff. That's Barnard's Loop, and really the magnitude just makes this game completely crashed. Show that off, but I see how it is, SpaceEngine. Let's go ahead and do this. Am I actually in the Milky Way galaxy? Oh, I am. That is the Milky Way. Okay, let's go ahead and scroll through here. There we go. And this is a planetary nebula, I think. Nope, that's diffuse. Where would a planetary nebula be? They're rather small, so they don't show up until you get really close to them. That might be a planetary nebula. Ooh, nice and colorful too. Diffuse. The planetary ones are typically like square-shaped. I don't know why they're square-shaped. Oh, wait. There's one. And it's square-shaped. I don't know why they're kind of square-shaped, but diffuse. Can I not find a planetary nebula? I assume these are planetary nebulas, but they're just labeled as diffuse. That might be a planetary nebula. Are you a planetary nebula? Diffuse. I am just not finding planetary nebulas at all. Oops, there we go. What about you? Nope, just make it a fool out of me. More diffuse nebulas. I guess diffuse nebulas are the most common. I think they might just be the same thing though. I'm not finding any. What about you? Are you? No, diffuse. You're a star cluster, you're not a nebula. You know, one thing I actually haven't seen, I don't think, is a star cluster with a nebula inside of it. Wouldn't that be, common or something? I don't see any of these star clusters ever with, like, nebulas inside of them. It's just... I mean, you'd think so. I mean, there's thousands upon thousands of stars inside here. Like, this doesn't even express nearly as many stars as there actually are inside this thing. If I turn up the magnitude, you can see all the finer stars just kind of orbiting in here. These are actually very, very dense. Compared to what the game might make you think. And with the magnitude turned up, you could actually get a real idea of how many stars you're actually flying by in the game, rather than by default when it looks like very, very little. No, galaxies are actually very, very, very dense with stars, as you can see here. And I imagine the encoding in the video is probably going all wacky because it doesn't like when you do fast movements with contrast and stuff. H.264 kind of freaks out when you do this. So I imagine if I spin my camera like this, it's probably turning into a pixelated blob, but I think I've been on this a little bit too long. So let's go ahead and move on to the next suggestion from Rarest Jaguar, YT, or Jaguar, depends how you want to pronounce it, potato. But here we go. Let's remove this question mark. Oh no, it's not actually coming up. What would be wrong in here? The Galaxy ID seems fine. Actually, no, shouldn't it have 4 segments? Let's remove the B3. No, it's not actually showing up. He says it's the weirdest planet with life, but it's not actually loading, so I'm gonna have to skip it. If you can try to correct that suggestion, I will be sure to visit in the next episode. But yeah, it doesn't seem to be loading, so I'm gonna have to skip over it. So the next one is from Lopsang Tashi Sherpa? I think I pronounced that right. I could be wrong. But let's see if this one works. No, it's not loading either. He says it is a very sexy planet. Well, it probably is, but I can't get the ID to actually load. So I guess I'm gonna have to skip this one too. I guess I'll move over to Black Op 345 Gaming, which his is a catalog star, so let's go ahead and try that out. Or cataloged object. It's a brown dwarf. Here it is. Oh, and it's got a beautiful pink Aurora effect and a huge sunspot. Look at that. I assume that was a huge storm, like you would see on a gas giant, but that looks pretty crazy. I love the detail in this one too. I think it has a nice texture mapping, but like I said, I think in my previous episode, I think it'd be cool if there was like a smaller detail layer in these stars, just to kind of add to it, like a little swirly effect. I think the gas giants kind of need it too. Because, I mean, there's like some really cool high-res, like, not NASA photos, but artist, like, renditions of gas giants and stuff, like Jupiter. NASA used it in one of its promotional videos, like the storms of Jupiter, and it was a really crazy effect actually seeing, like, the storms and stuff that it was all CGI, but it looked very cool, and I think that'd be awesome to actually see in the game. Kind of just expressed a little bit more like the storms in Jupiter and stuff. Really awesome brown dwarf. Let's see if we could actually visit some planets around it. Oh, we got a temperate Oceania actually really close by. Ooh, that is very hellish looking. You can see that on each hemisphere the clouds are actually moving in a different direction. Oh, and it's actually partially frozen, as you can see here. So while it may still technically be an Oceania, you can actually walk on the surface of this because it looks like it has an ice layer or something up here. Oh no. No, this might actually be land. This might not actually be a polar cap. It might actually be one of those bugged Oceanias. Let's turn up the luminosity. Or ambient lighting, not temperature. Okay, no, those are definitely polar caps. You can see a huge crack in the ice there. Very nice. Just smacked right into the planet. Whoa, am I upside down? I think I'm upside down. Looks like we have 2 layers of clouds. Let's fly over to the coast of this kind of polar cap. And you can see it kind of fades down into the water, which I don't normally see. Normally when I see a polar cap, it's just a huge, like, huge step in the ice, I guess. Like, you'll see like a huge difference between the sea level and the actual, like, polar cap itself. So, very interesting. I think this is where the ocean layer blending just kind of ends. Or that could just... Actually, no, I think that's where a cloud layer just merges into the polar cap. It actually has 3 cloud layers, as you can see. Very cool. Nice Oceania. Let's see if we could actually see the parent star. Actually, I have the ambient lighting turned up, so I might not be able to see it from this angle. Let's back out here. It's illuminated from this direction. Oh, there's the brown dwarf. It looks quite big in the sky, mainly because it's not really putting off much energy. In fact, this Oceania is actually sitting at negative 14 degrees Celsius, which is pretty warm for something orbiting around a brown dwarf. Very nice. And this song has a bird sound, I guess. Anyways, let's read his comment. It says, going back to a couple other videos in SpaceEngine, you said you couldn't find the planet with the longest orbital period. The full name of that planet is... Wait, this isn't a planet. It's not even a binary star, I don't think. No, this is just a... This is a brown dwarf. I think you got your ID incorrect, because, it orbits the star. No, this isn't orbiting anything in the game. Yeah, this is a brown dwarf you linked me. This is not the correct ID. Whoa. That's not what I wanted to do. Yeah. You're saying it's one of these planets? I don't think so. Orbital period. The longest orbital period is 4 years on this one. So yeah, this isn't a very long orbital period at all. Yeah, I think that's incorrect. You said it orbits this star, though. Let's see if this ID works. I don't think it will. It actually did. Let's try to visit this and see if I can find that planet. Okay. I think I might have actually visited this planet. I could be wrong. But apparently this has the longest orbital period. Let's see if we can actually see that star, which was off in this direction, I think. Is that the star? That is a star. Yeah, it looks very tiny. So that's a red dwarf, and this is a large frozen gas giant. Which, has about, a little over half the diameter of this red dwarf, it looks like. The mass... Okay, so it's a lot less massive than that red dwarf over there. But, yeah, it's actually orbiting pretty far. It's actually orbiting at a semi-major axis of 0.11 light years, so very far away. This was discovered direct imaging in 2016. Which, as you can imagine, if I turn the lighting to default, it's basically just black. It looks like a plain Nemo. So, yeah, this is apparently the furthest orbiting gas giant or something, planet with the furthest orbit, or largest semi-major axis. Obviously, these things change frequently, and people get their data incorrect, and there's a lot of data thrown around, there's a lot of papers submitted, things like that. So... this might be it, this might not be it. I could do some research. I'm probably gonna end up with the same results that a lot of people find. You'll Google things, you'll run across articles that are either outdated or just use outdated information and publish it wrong or something like that. And that is why a lot of people will suggest me things saying like, this is the farthest orbit or something like that. It's not necessarily their fault. It could just be whatever publication or resource they got it from's fault. So, I mean, that's why those kind of things like are sometimes incorrect. He says also look up HD ID. The planet with the largest orbit around a single star is 650 astronomical astronomical units away from the star that orbits it. Let's check that out. Get rid of that space. There we go. So direct imaging, frozen gas giant. It's not too far away from this one. We got a nice blue gas giant. It's ambiently blue. I turned down the ambient lighting, correct? Oh, no, I didn't. Okay, so yeah, it's just pitch black, just like the other one. Which it does still have an Aurora effect, which means it's still actually being affected by solar winds, I do believe. Or they could just be from energy and radiation generated inside this gas giant. Where's its parent star? Over there, apparently. Let's see. It's a distance of 650 astronomical units away. It is a white main sequence star. This gas giant was discovered by direct imaging in 2013. And let's check their diameter and difference. This one again is about half the diameter of that star right there. But it's about 1/10 the mass, so yeah. That's probably why this would be a planet. The diameter tells me that this thing's actually very close to becoming a brown dwarf, so it's almost like a dual star system, but it's not. You can't really see it there, but I mean it's orbiting right there, and there's a star way over here. There's no generated planets for this one since it is a catalog star. But very cool. So he says this is a planet with the largest orbit around a single star. So okay, so the last planet was the largest orbital period. This one's the largest orbital distance, I think is what you're trying to say. Okay. Or not what you're trying to say, but what you did say. Oh, does it have a moon? What's orbiting around it? Oh. Oh, never mind. Okay, it's a star. So it's not a highly eccentric orbit. Of course, we probably don't exactly know how this thing orbits. It could be incredibly eccentric because, like I said, the mass is like 1/10 the mass of that, so it probably would have like a more eccentric orbit, possibly. I don't think this would stabilize very well, but I could be wrong about that. But, very cool nonetheless. Let's go ahead and move on to the next suggestion, which is from Derp Sauce Gaming. Let's see. He wants me to visit NID 3.1 and 6. B is a brown dwarf. 3.1 is the sun orbiting a purple gas giant. 6 is a Titan. Okay, so let's go ahead and check this out. So B, brown dwarf. Let's be a binary star. Oh whoa. Okay, what's going on here? It's a brown dwarf actually orbiting very close to its parent star. Look at that huge Aurora. That looks very cool. Let's turn off the orbits. Like the nice yellow effect it's got going on. Got the standard purple and bluish color. And I love the fact that it's just got like these molten bands on the back side here. You can see that huge star there. Let's make it eclipse it. Yeah, it's a crazy looking eclipse. Cool. Very nice, like brown dwarf here. That is just a white main sequence star, I think. Yep. And it looks like just a tiny planet compared to this thing. Oh, look. A little spiral galaxy in the background, too. I think that's a standard. Oh, no, that's triangulum. So I can only assume I'm probably on the outskirts of the Andromeda Galaxy. Okay. And if I hit F2 while selecting this, I should be able to see the planets you're talking about. So you wanted me to check out 3.1. So here's 3 and 0.1, which is a warm Solana. Let's fix our ambient lighting. There we go, much better. Here is the true night sky of the planet. It has no real reflections other than this beautiful bright galaxy, also known as Andromeda. And over here we can see the parenting star somewhere around here. Maybe. It's making a liar of me. Oh, there it is. A beautiful star. And the reason why this is lit up, if you guys don't already know, is the same reason a full moon lights up our sky. Or why we probably light the moon during an eclipse or something like that. It's because this huge gas giant here, or our parenting planet, or our moon, would basically just be reflecting and illuminating it, giving this planet, or moon, a nice purple hue. So I guess that's the only thing, actually, not the only thing orbiting it, but the only, I don't know, I guess large moon. All these are just tiny asteroids, which, actually this one looks kind of big, to be honest. Nice round shape, too. And you can see that this, actually has some rather beautiful looking rings, and I think that's the shadow of one of those moons. Yeah, I believe that's what that is. Maybe a shadow of that asteroid. And it's got these beautiful, kind of compact rings, but they're actually very, very close to the gas giant itself, and the shadow on its atmosphere looks very cool. And it's one of those nice, detailed, textured gas giants. And you can see like the cloud layer right below us and the lovely shadow on the atmosphere. And if we go down here, we can just see the void. We're under the cloud layer now. Kind of just generates a solid thing that I can't actually fly into. Very nice. I also said 6 is a Titan. Let's check out the Titan. See, there's an Oceania here with polar caps. I just figured that was worth a quick visit. Just kind of like the one we visited previously, but this one's a lot brighter. Let's check out this Gold Titan here, which has a nice kind of rusty and gray color, it looks like. Oh, it certainly does. Actually, the water is what's gray on here. Let's go ahead and just land here. So we got some nice rivers cutting in through the ocean here. And some hills. I think I do still have real planet brightness enabled. So this is what the planet essentially looks like. It has a very kind of, I can only assume, iron-rich terrain that has like a kind of red color. It has nitrogen and CO2. I don't know what the compositions fully are. I don't actually see any oxygen. So if this was iron, it wouldn't really be oxidized, I don't think, but not sure. I know iron has a red appearance when it's oxidized, because that would essentially be rust. As you can see here, we have like a rock texture that's kind of eroded, it looks like. Nice rounded rocks, which means like water or some type of liquid has flown across them. It kind of rounded them out. So I think that's pretty fitting for the shoreline here. It looks like we just kind of have like some small hills going on. Very nice. Couple small peaks, mountains. No volcanic activity. We have a kind of rusty orange cyclone over here, though. I can only assume these oceans are probably something like liquid CO2, possibly. The temperature is minus 156 degrees, so I think that's enough to actually liquefy CO2, if not freeze it. But very cool Titan. Let's go ahead and move on to the next world. Let's see if I can get it copied here. It doesn't appear to be loading. Same galaxy. Let's remove this 164. Actually, let's remove this first. Oh, so let's remove the 164. Okay. No, there's no A. It's not a binary system, so this is all incorrect. Yeah, your second ID, I guess, just didn't work. Not sure, but oh no, never mind. It's not a proto system. Looks like it still led me to the correct galaxy though, so I did do that kind of correctly, I guess. Yeah, your second ID is not working, Derpsus Gaming. So if you want to repost it for the next video, I'll definitely check it out. Sterling, the God, all gamer, says, found a very sexy galaxy. Let's check out this absolutely sexy galaxy of his. Let's remove that question mark. Your sexy galaxy's not loading. Let's try removing the 7. Nope, still not loading. Oh, I see. You put RS, that means random star, not random galaxy. So let's remove the question mark again. And swap that S out for a G. Okay, so here we go. Oh, yeah, I've actually seen this texture before. I think, who was it? I think Andromeda has suggested a galaxy with the same texture. I always like this one. Let's see if I can, there we go. It was moving automatically. I like it because it looks like a collision, or like the aftermath of a collision between like a spiral galaxy and something else. You can see that it's kind of dragged out a little bit, like this kind of arm of the galaxy is just kind of spun out a little bit. But I like it because it actually has this cool little pocket over here, this little bright part. It's kind of hard to see once you fly towards it, but if I increase the magnitude to hopefully not too high, I should be able to possibly, if I don't fly past it like I just did, see some stars that are over here. Ah yes, here we go. You see this lovely like little cluster of stars in this little tiny pocket out here. Like here they are. So you could totally visit some stars that are just hanging out right here on the outskirts of this galaxy. And you have this lovely view of the galaxy. But yeah, a lot of these randomly generated galaxies, I believe they just have like a catalog of like 100 or something like galaxy textures, and it just generated based off that. Which means if any more were to be added, the procedural generation would completely change between version to version. Which is probably why versions in 0.9.7 do not actually work in 0.9.8. So, yeah. Basically, once you add like something to the scene, the entire value completely changes, procedural generation changes entirely. And yeah, it's just a really cool galaxy texture. I'm a big fan of this one. Anyways, let's go ahead and move on to the next suggestion, which is from Sizzling Bacon. He says he hopes this is correct, the ID means. I hope so too. So let's go ahead and select that and just paste it in. Here we go, a hot ice giant. Oh yeah, I still have my magnitude turned up. That looks very cool. Okay, so it's a hot ice giant. You can see that it's molten, the clouds are kind of glowing like a hellish red. There's a minor purple to it, and it has these lovely blue rings. With a little asteroid just kind of sitting here, hanging out inside its own little section of the rings. Hello, tiny asteroid. You can see it orbiting around because I actually have the time moving in the game right now. Shadow kind of going on there. And there's a parenting star, which I can only assume is a blue... yeah. I was about to say blue main sequence star, but I guess it's blue luminous supergiant. And it's apparently a binary system as well. Oh, it's actually got a black hole orbiting around it. Oh, that's a cool effect. You can see that it's kind of jagged and stuff. I think I have my black hole quality turned down. It's, no, I guess I don't. When I turn to the lowest, it gets all weird. Like 5 bazillion copies of the star just kind of orbiting there. Medium quality and then high quality. I don't know what the difference between medium and high is. I'm not seeing that. Maybe it's something to do with actually going into the black hole. Like this. No? Oh, wait. No. That's low quality. Medium, high. Yeah, not sure what the difference between medium and high is, other than probably just the actual quality of like the rendering, I guess. I don't know. Let's go back to that gas giant, which was, I think, this one, Scorched Ice Giant. This isn't the correct one. Oh, that one. Wow, that is actually very bright. I think it was this one. Beautiful blue rings. I'm a big fan of how this looks. Temperature of it is actually higher than most of these planets over here. I think that's because of possibly these moons orbiting around it. They could be heating up the gas giant itself, but I could be completely wrong about that. Not too sure. But it's a very cool looking planet. I do like the hellish red glow with like the beautiful blue rings. Nice wide rings too. Very nice suggestion. Let's check out this Selena here and see what it actually looks like from the Selena. Yeah, it looks almost like a brown dwarf just because of the kind of red glow around it. We got another hot ice giant over here, which has like a similar glow to it as well. Very nice. Let's check out the next suggestion, which is from Barry Selznick. So let's check it out. NGC 97 Galactic Cluster. NGC. What's NGC? I don't know what NGC is. 97 though. Oh yeah. It is Galactic Cluster, isn't it? We have an elliptical galaxy with a spiral galaxy next to it. And let's just turn up the galactic magnitude and see what we could actually see here. It doesn't do anything till about 16-ish. There we go. Okay, so this is just a cluster. Kind of a super cluster there. That's actually more of a cluster up here, but let's go ahead and check this out. Let's default this. No, default this. There we go. And it is an elliptical type galaxy, which I was actually replying to a comment, actually on one of Anton's videos that I made a comment on, the IC1101 video. And I was kind of saying that IC1101 looks very disappointing in the game. Because when you actually go to like any other elliptical galaxy, you can kind of see that there's like tons of stars around, which kind of gives you a better idea of like what its density is and how many, ooh, okay. how many stars there actually are, especially in these clusters. But yeah, when you actually fly through an elliptical galaxy, it does not appear to have that many stars. But if you turn up the magnitude even a little bit, you can see that these are incredibly, incredibly dense with stars. More dense than, well, our Milky Way galaxy. These are super dense with stars, because elliptical galaxies are believed to be basically made of multiple galactic collisions, kind of like cloud galaxies, like the Magellanic clouds, irregular galaxies. Irregular galaxies are like a fresh collision, and then like elliptical galaxies are kind of what form after the collision kind of stabilizes, I guess. If I go over to IC1101, let's go ahead and check this out. You'll see that it's just like a glow, kind of. And as I fly through, you just don't see that many stars, because it's so incredibly big. I always found the rendering of this galaxy kind of disappointing. It's not until you actually turn up the magnitude that you actually start to see stars. And once I get it up to about a magnitude of about 11, you can actually start to see kind of its true star density. And that might be the central star cluster? I don't know. Let's hit. Okay. You guys ready for this? And we're in the black hole. This behemoth of a black hole, which I've visited way too many times in this series and in my past videos. And yeah, you guys see 1101 black hole, which is just incredibly absurdly big in this game. But yeah, as you look around, you can kind of see a little bit more of like how many stars there actually are. And let's just run this up to like 13. There you go. So this is what it would probably more than likely appear like if you're actually inside of an elliptical galaxy. What's this? Oh, that's IC1101's black hole. Okay. Just a very bright ball over there. Yeah, as I fly across the screen, I imagine H.264 is just going nuts and the encoding's probably freaking out and turning pixelated as I fly through this, as is typical when you have like this kind of level of noise, as I mentioned earlier in the video. But yeah, that's kind of an idea of what it would be like to fly through a galaxy like this. And it would keep going. It would keep going all the way to the outskirts. This is the biggest galaxy we know of, a huge elliptical galaxy. And even out here where it gets darker and darker, I'm still just flying through tons and tons of stars. This appears to be like the very edge here that the game actually generates. So, yeah. That's just like a cool thing you could do to make IC1101 look a lot better. I actually have a dedicated video on that. What IC1101 really looks like. So now he wants me to visit Cygnus X3, which I might have actually visited in the past. That sounds way too familiar. Let's check it out. Get rid of that question mark. Ah yes, it's a neutron star. Yeah, with an accretion disk. Orbiting around this. The accretion disk is probably being formed because it's probably stealing mass from this. Isn't Cygnus X3 that... star that very frequently goes through like a nova event or something like that? It like steals mass from this star and just goes into a nova like constantly or something. I think that's what Cygnus X3 is. Am I correct about that? I don't know, I'd have to look into it. That's probably why this sounds so familiar. He didn't give me any description. I think he just told me to go to it. Let me just Google this real quick. Classified as a microquasar. Okay. Gamma ray bursts. It is located at about 23,000 light years away. It is heavily obscured by interstellar gas or dust or whatever. Okay. No, I don't think this is the one that goes nova occasionally. Oh, guess not. But, yeah, this is a neutron star, which I do think I still have visited. It might have been like X1 or something like that. I could be wrong. Why it has an accretion disk is because it's essentially stealing like hydrogen and stuff from its parent star here, or its kind of neighboring star, which gives it kind of this cool little oval effect, I guess. Maybe that's why it's shaped like that. Not sure. But, very cool. Let's go ahead and check out the next suggestions, which are from Andromeda. And this video is already 43 minutes. I'm kind of rambling and just going off on tangents, but oh well. It is a warm Terra. Okay, it's totally locked, and the cloud doesn't look like it finished rendering, or it's just kind of clipping through the terrain, which it looks like it's doing. Didn't he already have a suggestion in this galaxy? I think I recall this view. There's like, there's an irregular galaxy there. Where's that spiral galaxy I just saw? We're inside of an irregular galaxy, which tends to kill my frame rate a little bit. There's another irregular galaxy. There's a planetary nova, or nebula, I think. No, diffuse. It's lying to me. Oh, we're in a kind of proto-system as well. As you can see here, we have a bunch of asteroids, like kind of forming a nice ring around this star. Obviously, it's not as dense as it would actually be. I thought my game crashed there. And it looks like we have a hot gas giant, a nice large gas giant orbiting here. Go back to that Terra. Oh no, I'm getting the flickering bug. Quick, select a planet and get rid of this. I'm on the verge of crashing. And let's just touch down on this before my game crashes. Oh, no, it actually has active volcanoes on it, as you can see there. And is that a polar cap? I think that is. Very cool. The composition is CO2, water, sulfur dioxide, and nitrogen. It has its kind of primary gases in its atmosphere. And it looks like it might just be very cold or something. I'm seeing like snow caps and stuff. Its temperature is not cold at all. In fact, it's 74 degrees. So I wonder what that was covering that volcano. Maybe ash or something like that? It's actually a very warm planet. Of course, it could just be generating that because it is tidally locked, possibly. Not sure. Let's check out this volcano here and see if it's doing the same thing. Yeah, that looks like a polar cap, or like snow cap. Not polar cap, but a snow cap on that volcano. No, it's actually just a different texture, isn't it? So I guess that's not snow. Maybe it's just ash. And there's a beautiful red dwarf. Yeah, red dwarf in the daytime sky. Very nice. Now let's go ahead and zoom out and see what else we can spot. You see the kind of volumetric effect of the clouds in the galaxy just spiraling around us like that. And yeah, this spiral galaxy here. I always like this texture. Looks kind of cool. It really gives a nice, like, three-dimensional kind of appearance, I guess. It is 3D, but it doesn't look so, like, no, two-dimensional. And that's actually a very large, irregular galaxy. It's actually pretty much as big, if not bigger, than that spiral galaxy. And here's that standard ring galaxy. Up here, it looks like we have the same galaxy texture as that one down there, but a lot smaller, I think. If not, very similar. Very cool. Oh, look at this dense cluster over here. Okay. It was just the angle I was looking at it from. There's actually like 4 galaxies orbiting next to each other right here. Very nice. And let's check out the next suggestion from Andromeda in a completely different galaxy. Let's remove that question mark. And here we go. Pretty sure my game's on the verge of crashing. It is a binary system. Let's see if we can just zoom in a little bit closer. Okay. Ooh. Oh, wow. Have I been here before? If not, then, look at that, it's just a huge line of elliptical galaxies. Look at all these galaxies around us. Jeez. They just keep going. There's another one over there. There's more behind me. Oh, okay. Oh, there goes the game. I knew it was going to crash eventually, as soon as I brought up that star menu. Okay, let me just reload it real quick. Initializing engine, loading stars, loading planets, blah blah blah. There we go. And wait for it to kind of pop into OBS here. There it goes. Okay, let's get rid of this question mark. It doesn't look like it put me too far away. You know, it does actually have a semi-major axis of 915 astronomical units, which tells me that it is actually orbiting that system there. So, let's see. We have a planet with life. Is it a moon with life? Oh, that's kind of interesting. Does this have a life? No, it doesn't have life, but its kind of binary gas giant twin over here does have life. That's interesting. Do I have real planet brightness on? Let's turn that off so we can actually see these worlds. So that's interesting. One of these gas giants has life, but the other one doesn't. That's actually very cool. And if we hit... Yeah, it was actually, it's panspermia, so... Went quiet there, I had to sneeze, but, Yeah, it's just kind of funny that, that gas giant there, its moon, or, well, I mean, it's probably a binary system. It certainly is. Has life, but the main one doesn't. That's, I don't know, kind of interesting. I would think that would just kind of affect the other world. So let's select one of these stars again. And let's go back. And let's check out the other planet with life, which would be over here. A cool desert with life. Okay, so it's tidally locked. As you can see, it's got like a polar hemisphere, because that part's never actually facing the star. It's facing that galaxy. At least it has a beautiful night sky. This night sky is already crazy, but yeah, we got some nice purple life, as is pretty typical on these kind of desert worlds. You can see there's a little bit of snow on the top of this volcano here. The volcano does look like it's actually active. There's snow all over the ground. We have some beautiful cloud layers, some nice bands going across the sky because of the giant storm or cyclone across the planet. Let's just go ahead and play and watch this one actually orbit. Oh, you can see it actually has a lot of moons just kind of orbiting around it too. I wonder if I can get a nice thumbnail of like all these galaxies and this planet here. Let's let it go a little bit further in its orbit. I think I could probably do something like that. Reverse this, and then I might get a better view. Oh, too fast. Okay, let's reverse it again. Hit play. Oh. Oh. Up. Up. There we go. Right there. I like that view. Maybe like this? No. Right here in this corner. There we go. How's that for a thumbnail? I think that would make a very cool thumbnail. Maybe. Maybe up here. Because I'm going to have like the SpaceEngine logo up here in the top left corner, and then like the part number right there, right here seems good. I like this. This right here. Can I decrease the field of view at all? Yeah, I can. Okay, there we go. That's thumbnail material, I would say. Let's just copy this into something. Let's go paint. There we go. Anyways, nice thumbnail. Let's go and move on to the next suggestion, which is from F Diggity Dog. And let's reset our field of view. There we go. And here we go, a Scorched gas giant. Okay, this is orbiting very close to the star, I could already tell. Osiris, HD 209458b. And here comes the parenting star. There it is. So it's discovered by transit in 1999. That's effects on the kind of light of the star. It sits at a temperature of 926 degrees. And has a semi-major axis of 7.1 million kilometers? Yes. So not too far from the star. As you see, it's quite big in comparison to the star, and we have this huge comet tail, which if we zoom out, just spans across the system. Let's get it rotated to where the refraction spike isn't blending into it. And you can just see it keeps going. In fact, if I go over to the settings here, I can actually turn that up. Let's turn up comet brightness. There you go. That's a good view of comet tail. So it spans all the way across the system. Nice and beautiful. Let's fix that. Actually, let's boost that up by a small value. There we go. Keep it nice and visible. So very nice. Sitting at 926 degrees Celsius, so a very, very hot planet, as you would expect, being this close to a yellow main sequence star. Yeah, yellow main sequence star. It's probably that. The game likes to label main sequence stars as dwarfs sometimes. I don't really know. I mean, maybe technically, but I don't know. But yeah, very cool. The orbital period is... So it takes 3.5 Earth days to actually orbit around here. Pretty nice. So let's go ahead and move on to the next suggestion. Once again from FJ Dog. He says this is the least eccentric orbit, by the way. So it's going to be incredibly round, possibly? Oh. Does it actually mention eccentricity in here? I don't think so. Anyways, let's go ahead and check out the next one, which is the largest orbit around a single star. Here we go. That's a star. And that's a big orbit. Direct imaging 2015. Wait. Or 2013, I mean. This is literally the planet I visited just earlier in the video, actually. It's the same one that Black Op 345 Gaming suggested, so yeah. It's the same blue world. Okay, well that's a bit weird, but yeah, same suggestion in the same video. There you go. I think that's a new milestone, I think. Let's see, let's check out the next suggestion from Longle Ben SMB. I can't pronounce that. That doesn't... I can't vocabulate. Let's go ahead and check it out. Oh, no, let's try A. There we go. Okay, so it's a kind of binary twin orbit of 2 stars, and what is this? Another star or a brown dwarf? A dwarf. So far. Yeah, I think it's just 3 stars. I think you actually wanted me to visit here. Is there any planets? No, it's just 3 stars. Kind of like a little triple orbit. Very nice. It is cataloged. I like the kind of little red dwarf there. I think that kind of adds to it. That means that red dwarf is making this, I assume, orange dwarf? Yeah, orbit around each other. Very cool, and it's just orbiting around this kind of greater mass over here, which I can only assume is like a main sequence star of some kind. Yellow dwarf. Probably a yellow main sequence star. Very cool. This next one's from Tessune. Let's check it out. It says binary star system that has 3 planets with life, located in the small Magellanic cloud. So let's go ahead and check that out. And here we go. Okay, so we have a tidally locked planet here. It is a warm terra with life. Looks like we have some snow on these volcanoes. It has a temperature of 69 degrees Celsius. So, relatively warm for snow caps to be forming like that. Especially on its tidally locked region. Orange atmosphere, and really shiny snow on the side of this volcano. Volcanic activity, as is very common with tidally locked planets, and a very low-lying cloud layer right here. Fog layer. But yeah, look how low these clouds are. And then you have like this higher altitude one right here. And you got some rivers that tried to generate, kind of did, but it's like evaporated away over towards like the hotter region of the planet or something. I don't think that's like a intentional thing to generate, but I think it just did that anyways. Kind of fitting. And you have some nice eroded hills here with some snow peaks, I guess. Very cool. See if we can just zoom in here and see some more life textures. I don't think that's the life texture. Let's fly over to the warmer planet side of the planet, where we'll probably get a nicer view of it. Okay, let's slow down here. That might be the life texture. Yeah, it looks like that kind of like a dry, deserty terrain with like some trees. Possibly. I'm only assuming that because of the, well, this section right here. Let me see if I can find an area that shows it more clearly. Yeah, I think that's what that is. That might just be the grass. Yeah, wait. Okay, yeah, I'm seeing two different life textures. I'm seeing that star-shaped grass texture that looks like ferns, I guess. And I can't quite make out any of this, to be honest. Only really that fern texture. Okay, yeah, that's the standard grass texture. So it looks like the grass texture and that fern texture. Very cool. This has 3 planets with life, so let's see if we can... No, wait, this is the wrong system. Here we go. We have a tidally locked Oceania with life. Of course it's marine life, and we won't actually see it, but I see something cool happening here. Since it's a tidally locked Oceania... Cool. So it's like a half snowball world. You can see that lovely shine on it. Is that from a big moon or something? Oh, it's from the other star. Oh, very cool. That's pretty neat. Actually seen an Oceania like this in a long while. You see the huge cracks in the glaciers. Very nice. Is this the planet I was just at? Yeah, I think it is. You can see it's kind of illuminated from the other star as well. Let's check out the other star, which has a cold ice world with subglacial life, so I'm not actually able to see it. There it is, kind of a lovely disco world with kind of an orangish green color and a very vibrant hot pink color. When blended together, it kind of makes an orange color. Like right here. Oh, very nice. Let's check out the next suggestion from him, and it is, or her, from Tasuni. Purple Titan with life orbiting a white dwarf. Also located in a small Magellanic cloud. Get rid of that. Here we go. Oh, it's a lovely blue world with a huge crater, it looks like. A couple huge craters, possibly. Let's go ahead and zoom right into this. Got, like, some lovely dark rings as well. Oh, wow. This looks kind of cool. Oh, it's not the canyon terrain. I thought it was canyon terrain. No, it's actually the, kind of typical mountains with a nice erosion effect, as you can see here, just kind of banding down the sides of them. It is terrestrial life. It's exotic life, though. So I assume this blue is our life texture, as you can kind of see here. And the white I can only assume is like some kind of frost or something. Very nice. Let's turn on real planet brightness, because this is what you gotta do for Titans. Oh, wow. Okay, that really changed its appearance. You see the Magellanic cloud just kind of glowing there, the blue star. Looks like blue main sequence, possibly. White dwarf. There's the Milky Way galaxy. I guess it's a white dwarf. To the Titan. Exotic life in a very, very cold world. And if we land pretty much anywhere on this planet, if we look at the night sky, you see the Milky Way galaxy. Somebody told me that if I set the exposure over here. The reason why I've been seeing so many stars in the sky is because I have auto exposure off. If I turn it on, this is essentially what it would actually look like, I guess. But I don't know. I think of auto exposure like a camera setting, not this. But he could be correct. I imagine if it was dim like this, you might be able to actually see, like, the galaxy, though. But, not sure. So, let's check out the other suggestion from Talongalben SNB. He kind of posted it as 2 separate comments, so let's go back to one of his suggestions, which is Kepler 442b. Not found. Let's see if I can find it. It's because he didn't put the dash, I don't think. There it is. And here we go. Scorched Desert. Right here in the Milky Way galaxy, of course. What? That's orbiting. It's like, this is real time. It actually has a orbital period of... Oh no, wait. Never mind, that was my control stuck. I was about to say, is it really orbiting that fast? No, it's not. 112 days. But yeah, it's a very, very hot scorched desert orbiting very close to this star, I guess? Well, look at that evaporation of the planet there. What is this? An orange dwarf, okay. This poor little desert here just being cooked away. And let's just fly right in. Wow, look how bright that is. This is real planet brightness, I think. Let's fly over to the kind of sunset of this world. Right over here. I've explained it many times before. This kind of dark angle on the atmosphere here is the shadow of the planet being casted across its atmosphere. And it's quite dramatic with these worlds. And yeah, I don't even know what type of layers I'm flying through right now. Like, look at this. We have a black layer. Kind of a grayish layer. A red layer. We have, like, I guess the surface layer? So I assume that's 3 different cloud layers with like 3 different levels of shading on them. Very cool. Very hot world. Sitting at 1,231 degrees. I can only assume it's just molten lava under there. Let's check out the last suggestions, which are from Mr. Star Wars. Wants me to visit a planet that's in a random star cluster, so let's go ahead and check that out. Oh, got a question mark here. That. Temperate terror with life. Okay, let these clouds render in. Nice detailed clouds once they actually pop in. We got some beautiful rings. Oh, actually kind of a vibrant greenish tan color, I would say. And, yeah, there's a lot of clouds on this world. Let's, turn water off. Let's turn the clouds off. Yeah, it's actually a lot of ocean. Kind of like our very own world. And look at this amazing view of this galaxy. That's very cool. So we're in a star cluster, probably orbiting somewhere above this galaxy. I always love this galaxy texture. It's always been, like, pretty much my favorite one. And, let's turn off the clouds again. Try to find something that's kind of in the sunset region. Right here, what might do. It's back on, and we would just see like these beautiful bright stars from the star cluster, and there's our rings just kind of rainbowing over the horizon. And our life texture looks like the grass texture blended in with like kind of the generic life texture. Generic life, I mean, it looks like some type of forest or something. Yep, that's what that looks like. Very cool. We have these nice rounded hills, and mostly just this beautiful night sky. Or actually, this is daytime sky. My bad. Crazy looking. And he says, I found this guy around a white dwarf. I think it's rare to actually find these types orbiting around a white dwarf. Let's check it out. not too far off. What is this? Oh, it's a Temperatura with life, with a lovely blue color. Same galaxy, and a nearby star cluster. And that is our white dwarf, which is obviously... Actually, I kind of explained it, I guess, in my last video, the Universe Sandbox 2 video, what a white dwarf is. It's basically the core of a star that's lost its outer shell after going through its nova event. So yeah, it's actually kind of interesting that this has life on it after a star that's gone nova, but... Very beautiful. Look at that awesome Aurora effect with this lovely blue world. Actually really awesome. Oh man. This might have thumbnail potential, possibly. I think I want to stick with the Galaxy one, but that definitely make a really awesome looking thumbnail, wouldn't you agree? Got the beautiful Aurora, which I can actually go into the settings here and just kind of perk it up a bit by just turning up the Aurora effect. Look at that beautiful view. And that is the last suggestion for this video, so I think I'm going to end it off here. Let's just go ahead and speed up time a little bit and just watch these Auroras just kind of flicker through. Anyways, if you guys like the video, please leave it a like, and if you want to see more videos like this, please do subscribe, it really does help. And I will see you guys in the next one. Oh, and like I said, if you're going to make suggestions, do it on the latest SpaceEngine video, because I'm no longer looking at suggestions that are like slapped onto previous episodes or on my Universe Sandbox videos. I only look at the latest SpaceEngine videos. So yeah, if you have a suggestion, do make it on this episode. It will be in the next one, and so on. Anyways, see you guys.